In this video, we're going to talk about Venn diagrams. Now, a Venn diagram is something we have seen a couple times, kind of inadvertently in previous material, but let's kind of discuss them a little bit more formally and start with the basics. So a Venn diagram is a way to visualize sets, which we've talked about. So like, for instance, let's say I start with the set of numbers from 1 to 10. And I am referring to whole numbers, or I could call those integers as well. And this set is going to represent my universe, all the set containing everything I'm looking at right now. All right. And then let's say we have a set A, and let's say this set is 1, 2, 4, and 8. All right. So if I wanted to visualize this, this is how I could use a Venn diagram. I'm going to go ahead and draw the universe. Now, we called S previously when we looked at sets sample space. And we're also going to treat it, as I just said a second ago, like what we're going to call the universe. It's what we're looking at right now. That looks like an H, not an N. Let's fix it. Universe, a little better. Okay. So it is our sample set. It's or sample space. It's the space that we're looking at right now. But yeah, in Venn diagram language, we usually call that the universe. Okay. So out here is S, and then inside of S is the set A. And then of course, within set A are these numbers. So here, let me go ahead and put those numbers in here. So 1, 2, 4, and 8 are all sitting in the set A. Okay, so then not in set A would be the numbers 3, 5, 6, 7, 9, and 10. So outside of A, sitting in the universe are these other elements, these 6 numbers, and then inside of A are 1, 2, 4, and 8. Okay, cool. So that's how a Venn diagram could look for that information. So let's then create a new set. Let's call this set B. And let's say B is, how about the odd numbers? Okay, so let's now look at the universe with A and B in it. Okay, so here, let me just rewrite A, even though I have it in that picture, because I just want to reference it here. Okay, so let's redraw my Venn diagram. And this time, I have 2 sets, A and B. Let me give myself a little bit more room. There we go. A and B. Now you notice I made A and B overlap, and that's because A and B have some elements in common. So here's S sitting out here. So A and B have, let's see, they have the number 1 in common, and that's it. They have 1 element in common. So when I put the number 1 here, I want to put it in their overlap so that it's sitting in both A and B. But then in A, I want to put the numbers 2, 4, 8. And then in B, I'm going to have 3, 5, 7, 9. And then in the universe, let's see, I'm missing the number 6 and 10. So those 2 numbers are sitting out here in the universe, not included in A and B. And there you go. That's how we can represent information visually rather than in a list in the roster notation. Okay, so let's kind of generalize it a little bit more, or actually I want to look at some more specific examples. Let's say, let's create the set C now. Same, I'm going to use the same universe, but let's say C is 2, 4, 6, 8, 10. Okay, So C is basically everything B isn't. C is all the even numbers, B is all the odd numbers. So if I wanted to draw a Venn diagram of that, I wouldn't want them to have an overlap because they don't have anything in common. So this would be B, this would be C, and then in B we have all of the odd numbers, 5, 7, 9. C is going to have the even numbers, 2, 4, 6, 8, 10. Oops. 10. And nothing else is left to be inside the space S. That's actually everything inside of S. But that's how we could visualize it. So when you draw the two sets separate like that, we have a name for it. That's called disjoint. Disjoint, or when the sets have nothing in common. Wow, that is not how you spell joint. Disjoint. There we go. Sets, or two sets that have nothing in common. All right. Okay, so let me introduce a fourth set. Let's call it D. And let's say D is 2 and 4. Okay, now, based on C and D, which I have here on my screen, I can see that D is basically a subset of C. Everything that's in D is also in C, but C is a little bit bigger. Visually then, if I were to draw that as a Venn diagram, here's how that would look. And we have seen this before when we first introduced sets. So we have C, and then we have D inside of C. And D, here we'll do it in blue, would contain the numbers 2 and 4. C would contain 6 and 8. So 2 and 4 are still in C, but so is 6 and 8 and 10. Sorry, keep forgetting 10 for some reason. And then all the rest of the numbers, the odd numbers, would be sitting out here in the universe of S. Sometimes they call the universe U, by the way, just because it makes sense since we're using that terminology. So be aware, they might use the word U or the letter U instead of S. They're the same. They represent the whole group that we're looking at. Okay, so you're like, now I kind of understand these different visualizations. Let me just make a note here that what we're really looking at is a subset scenario here. So we have a subset, and that's what this visualizes for us, that we have this smaller little set inside the bigger set. Okay. So let's look at some examples of how this might kind of play out, different ways we could look at this. So I'm going to look at 2 different examples. So let's say that we're asked to draw a Venn diagram to represent these 2 sets. So let's say A is odd numbers and B is multiples of 3. And then we're given one more piece of information that our universe in this example is the numbers 1 through 9. So I'm going to go ahead and use the U symbol for universe since I mentioned it a second ago. Okay, so I want to draw a Venn diagram of this. So I will start by drawing my box. So in this case, do I want to draw it where the 2 circles are separate, where they have an overlap, or where one is inside the other? So I kind of need to maybe look at what A and B are. So if A is odd numbers, and this is our universe, then A would be 1, 3, 5, 7, and 9. Okay. Multiples of 3. Well, that would be the number 3. Also the number 6, because 2 times 3 is 6. And then 3 times 3 is 9. So those are multiples of 3. Okay. So looking at A and B, I do have 2 things in common. I have the 3 and the 9 in common. So I do want to draw this with an overlap. So here's A, here's B, and then 3 and 9 will be here in the middle. Sorry, it's kind of a sad 9. There we go, a little better. And then 1, 5, 7 will be sitting over here in A. 6 will be sitting here in B. And then outside of both of them in the universe will be, let's see, 2, 4, and 8. Yep, there we go. Got them all. All right. So that's how we could draw that Venn diagram. Okay, but let's look at something a little bit more general. And this is actually where it's going to get a little bit more effective for us, and kind of what we've seen when we looked at probability previously. So let's say, and this is a slightly silly example, forgive me, 110 dogs were asked, why do you eat garbage? I know, silly. And they are able to answer us and tell us. And their answers were, 89 of them told us that it tastes good, or it tastes great. That's actually the phrase they used. 87 said it's filling. Actually, it's more filling. They're using a play on an old commercial. And 68 of those adorable dogs said that it both tastes great and is more filling. So they liked both answers. All right, squeezing that in there. So let's draw a Venn diagram of this information. So this time, the universe is the 110 dogs that were questioned, okay? And what we really have are two main responses. It tastes great, or it's more filling. Now, it's possible that there might be additional responses, but these were the most common responses, so we want to include that in our Venn diagram. Okay, I'm gonna have to zoom out a little because I ran out of page space. Oh, it got mad at me for zooming out. Sorry about that, guys. Give it a second to, there we go. All right, so here. I'm gonna go ahead and draw my Venn diagram right here. Okay, so one set of responses that it tastes great. Let's go ahead and call that G for great. And then more filling, that'll be F for filling. Okay, so this will be G, and then this will be F. Notice I'm going to draw it where they have overlap. And the reason is there were dogs that both thought it tastes great and was more filling. Okay, in fact, 68 dogs who thought that. So I'm going to put the number 68 right here. So there were 68 dogs who thought it was both of these responses. Okay, but then we're told that 89 dogs said it tastes great. Now, that 89 includes the 68 that said it was both. So I need to actually subtract 68 from 89. And I get 21. So what that means is there were 21 dogs who said it just tastes great. I don't think it's filling, it just tastes great. But there were 68 dogs who said it tastes great and it's filling. So together, those two combine to be 89. All right. So that's where the 21 is coming from. We are taking 89 and minusing 68. Okay. So same idea then for filling. There were 87 dogs that said it was filling. So I need to subtract that And 87 minus 68 is going to come out to 19. So that's taking the 87 and subtracting the 68. All right. Now, what I'm interested in is, of those 110 dogs, does this account for all of the dogs? So if I add up 21 plus 68 plus 19, I actually get a total of 108, which means there were 2 dogs that didn't say that. They said something else. All right. Okay, so now that we've drawn the Venn diagram, they're going to ask us a series of questions. The first is, how many said it's more filling, but didn't say it tastes great? And the answer is pretty straightforward because it's sitting right here on our on our table. That's 19. There were 19 dogs that said that it was filling, but didn't think that necessarily that meant it tastes great. They just liked the filling. Okay. Part C asks, how many said neither of those things? And the answer would be 2. Because again, we figured out that 2 dogs, oops. Okay, sorry, got mad at me for what I just did there. Hold on, let me see if I can undo it and make it happier. Undo. There we go. Okay. How many said neither? And the answer is 2 dogs. Sorry, I like messed with the writing by accidentally bumping it. Okay, and then last question. How many said it's more filling or it tastes great? It's filling. Oh, sorry, more filling. It's more filling or it tastes great. Okay, so it's an or question, and that's supposed to say many, not may. How many said it's more filling or it tastes great? So the or implies that they could answer either way. So there were 21 who said it tastes great, only 68 who said both, and 19 who said filling. So that would categorize people who said one or the other. So those 3 numbers are going to satisfy this requirement. So I'm going to add 21, 68, and 19. Which I actually already did earlier and got 108. So 108 dogs said this. So once we have the Venn diagram, it's like really easy to answer these questions. Even not knowing all of the specific answers, just the numbers of people, or in this case, dogs, that answer these questions for us. And that's one way we use Venn diagrams.